This is a surprise pop test. Uh, A8 engine performance. Maybe it'll help you a little bit. We'll see. It's one of the things I tell people when they ask me about how to study for an ASE test is, to me, the best study for an ASE test is the work you do in the field. There are some people that say ASE tests are all they do is prove that you can take a test and whatnot. But that is a credentialing thing. And the job I got as an instructor, I never would have got that job if I wasn't ASE certified. The motor age riding that I did, that began in May of 2000 and lasted for 20 years, I would have never got my foot in that door had I not been ASE certified in all 8 basic categories. So ASE certification carries weight more than you think it does, because it is a credential that you can show that you have, and credentialing is important regardless of what your industry is. And so I'm going to jump into this little 10 question, and we'll do the 10 questions first, and then we'll go and do the answers, which is typically the way that I do this kind of stuff. All right, test question 1 is, a baro reading that falsely indicates high altitude will cause an engine to run A, rich, B, hot, C, lean, D, cold. All right, that's the first one. Question 2. The most reliable way to determine if a mass airflow sensor reading is acceptable is to A, compare to published specs, B, measure the hertz or voltage, C, watch the fuel trim readings, or D, compare to a known good sensor. Test question 3. When the throttle is open, TP voltage and blank voltage should closely follow each other. RPM, CAM, MAF, IC. Test question 4. Which of the following is continuously monitored? TP and ECT sensor, catalyst and evap, EGR and fuel trim, or hydrocarbon factor? Test question 5. Which of the following is the least likely to be the cause of induction backfire? A, lean air fuel mixture, B, bad mass airflow sensor, C, downstream O2 sensor, or D, crossed plug wires. Test question 6. O2 sensor values that read lean on hard acceleration may be caused by A, uncommanded EGR flow, B, kinked or pinched return line, C, fuel pump circuit voltage drop, or D, stuck closed injector relay. Now test question 7. A suddenly misfiring cylinder due to a bridged spark plug can cause A, a lean O2 signal and higher fuel trims, B, a rich O2 signal and lower fuel trims, C, all injectors to begin to fire sequentially, or D, unauthorized evap and EGR activation. Test question 8. An open intake air temperature sensor can cause A, hard starting, B, induction pop, C, no symptoms, or D, an ECT code. Test question 9. A vehicle was written up for power loss under acceleration. What is the smartest first step? First, would you check fuel pressure, check spark timing, verify the concern, or retrieve all diagnostic trouble codes? Test question 10. While releasing the throttle, or when releasing the throttle, the engine intermittently fails to fully return to idle. Which would possibly cause this? MAF reading hertz, TP reading part throttle, TP reading closed throttle, IAC stuck shut. All right, now here's your answers, and we'll talk about these as we go. A baro reading that falsely indicates high altitude will cause an engine to run lean. Now, a lean mixture burns hotter than a rich mixture, but won't cause the engine to overheat, except in very extreme circumstances. If it doesn't think there's as much air, it's going to put less fuel in there. And there was a Jeep one time that this buddy of mine was working on, and it had tossed him a bunch of lean codes, and we'd seen oxygen sensors flatline and caused that, and he threw an oxygen sensor at it and it didn't fix it. And what you do is you look at your fuel trims. Whenever you first crack into that data stream, if the long fuel trim is way out of kilter and the short fuel trim is at 0, it means the long fuel trim has had to go way out of kilter to put the short fuel trim back at 0. Its job is to keep the short fuel trim near 0, because that means it's doing a balancing act to keep the emissions as clean as they can be, despite any unbalancing situation to the richer lean side. So if what he had done was he incorrectly assumed the oxygen sensor wasn't telling the truth when actually it was, the fuel trims were up around 27% plus. And so whenever I looked at his scan tool, he and I were looking at it together, because I just happened to go by. This was after I started teaching, and I was over there on a Friday. And I says, look at this barometric pressure. Today's prevailing barometric pressure is, about 29. This is showing 22. And I said, this is a problem, and that's going to be the reason that you're running lean and correcting to the rich side. So he went and got a map sensor from the parts department and popped it on there, evened everything out. Here's the caveat. After you've done a repair, what you need to do while you're doing the repair, take the battery cable off, let it forget everything it knows as far as adaptive learning from the fuel trim and everything else. Now, sometimes you may have to clean the throttle body because it doesn't want to idle good because of the adaptive learning of the idle circuit. But fire that thing up. Look at that short fuel trim. If that short fuel trim, when it closes loop, hovers close to 0, you're good. If the short fuel trim starts to walk really fast one way or another, you're not done. You got to fix it so that that short fuel trim is hanging around right close to 0 within a point or two on either side of it. Maybe going up and down a little bit, but centering on 0. And that's how you tell right away if you've found all of your problems. You may have found a crack or a leak or a vacuum leak or whatever, bad sensor, but you definitely need to double check by watching that short fuel trim. If you ever want to see how this works, for example, and how sensitive this thing is, on a lot of these vehicles, just about any of them, you can be looking at your fuel trims and have them both come near 0. Take the oil filler cap off. If it's not one of those that's got the timing chain right under the oil filler cap. Take the oil filler cap off. Usually there's a baffle under there, and the PCV will start pulling air through that open oil fill, and it will start driving those fuel trims off kilter. Just experiment with that. That's an extremely sensitive, tight adjustment there. Anyway, the most reliable way to determine if a mass airflow sensor reading is acceptable is to compare a known good sensor. I know that sounds ridiculous because you may not have a known good sensor, and a lot of the times the parts house, if you're buying it from the parts store, if you buy an electronic part and you try it, they don't want to take it back. But the shop manuals on a lot of these electronic parts for years would say try a known good part. Well, that only works if you have a known good part. The mass airflow sensor reading can be off just a fraction and still affect fuel trim. I talked about that some last week. And so comparing a known good sensor, you remember the Ranger I was talking about that was healthy and had good fuel trims, and all I did was put a mass airflow sensor that was reading just a tiny bit off, and the fuel trims would dive off in one direction because the oxygen sensor was picking up that there was the wrong amount of fuel going in there, and it was the engine controller was depending on that input to determine what to do with fuel trim. And the fuel trim was thrown off by a mass airflow reading that was inaccurate. And it wasn't inaccurate by enough that you could spot it with your naked eye unless you compared it to another good sensor. That's the point. When the throttle position, when the throttle's open, TP voltage and mass airflow should be following each other. You're going to see that. If you ever do that, pull your TP and your mass airflow up on the same tracking screen. Apply your throttle, you'll see them jump together. Now this right here, this thing that I'm showing you here, these are accelerator pedal position sensors on my Explorer is what this is. And you can see how sometimes they mirror one another, depending on what kind of car it is. Sometimes they follow one another and the voltages will be different and all that kind of thing. It's a redundancy deal. I just put that up there for an illustration. Test question 4. Which of the following is continuously monitored? The TP and the ECT sensor. Everything else, this is bogus here. This is not even a deal. I used to throw these things in there, and you know, it sounds good, but there's nothing to it. One of my students was scratching his head because on one of the tests I wrote when I was at the college, one of the answers I put was heated hydrocarbon vent. That was just something I made up. Kind of like hydrocarbon factor. I mean, you know, it's, you can actually read that if you've got an exhaust gas analyzer, but that's not the point. So continually monitored, you got TP and ECT. You couldn't say the oxygen sensor does this because the oxygen sensor doesn't smell fuel. All it cares about is oxygen. But the EGR and fuel trim, catalyst and evap, conditions have to be met before these can be checked. Conditions have to be met before this can be checked. And there's, like I say, this one here I consider kind of bogus. But the throttle position sensor and the ECT sensor are checked all the time. But they can have in-range failures that the PCM will miss, kind of like the mass airflow sensor I was talking about from last week. All right, which of the following is the least likely to be the cause of induction backfire? Downstream O2 sensor is not going to be the cause of that. Now, I will tell you that if the upstream O2 sensor goes flat on a lot of these vehicles, it will start using the downstream sensor to adjust fuel trim because it's wanting to keep the catalytic converter happy. That's the whole deal. And if it can't trust the upstream and it knows it can't trust it, it will begin to take input from the downstream O2 sensor. This picture was sent to me by a guy that I know that owns a tire store. And this is an aluminum upper intake, and it backfired hard enough on this one to where it broke the upper intake. But cross plug wires can make it backfire. Bad mass airflow sensor is reading really, really lean. This is sort of rare. Lean air fuel mixture can make an induction backfire, but this kind of an induction backfire is going to be very, very serious due to ignition being crossed up. But the other ones, can cause it. They just won't blow the top off the manifold. O2 sensor values that read lean on hard acceleration may be caused by fuel pump circuit voltage drop. If the fuel pump's not getting enough voltage, and it's not going to, there won't be enough fuel in there, and it's going to make it go lean. Uncommanded EGR flow will actually make it drift a little bit rich. Make it idle rough, but driving down the road, it would drift a little rich. Kinked or pinched return line would raise the fuel pressure, and that's not going to make it, read lean on acceleration. Stuck closed injector relay is just going to keep the injectors powered up, but it's not going to trigger them so that they're open all the time or anything like that. So, and it won't prevent them from being triggered. If I put stuck open injector relay, that might have been a little bit different. But the long and the short of it is, if you get on the throttle real hard and the oxygen sensor goes lean and you're feeling a loss of power, I'd be looking at fuel pressure just to see what was going on. And fuel pump circuit voltage drop can cause that. That being said, some of the earlier vehicles, right after the fuel injection years started, like for example Jeeps had a current dropping resistor, so there was only about 8 volts going to the fuel pump after you started it. They did that to keep the fuel pump from making so much noise. Crown Victorias and Lincolns had a resistor wire that was bypassed when you were starting the vehicle, but when you came back to start, that resistor wire would reduce the amount of voltage going to the pump. And that tended to cause problems later on and had to be undone. So it doesn't need that current dropping resistor for any other reason than pump noise. I don't know if you've seen that before, but that was a thing in the early days. Question 7. A bridged spark plug suddenly misfiring will cause a lean O2 signal and higher fuel trims because it will send unburned fuel and oxygen or air into the exhaust stream, and the O2 sensor doesn't see the fuel, only the air, and fuel trim increases. Now, when the entire engine begins to be affected by this, it's a fruit basket turnover. Furthermore, on just about every platform out there now, if if one cylinder begins to misfire, the engine controller will shut the fuel off to that cylinder. You can test that by killing a cylinder by unplugging an injector or whatever while you're listening to with your stethoscope or using your little light flashing tool. I'm not talking about unplugging the injector, but because that was stupid to say that. If you kill that cylinder any kind of way, like you short the spark plug, unplug the cop coil, is what I was thinking, and I said injector. And so if you unplug the cop coil, it starts misfiring on that cylinder. If you're listening to that injector, you will typically hear it stop clicking because it's detected a misfire on that cylinder. It doesn't want that fuel going in there and cooking the cat. So that's why they did it. Remember, these systems, these algorithms are largely written to protect the catalytic converter in as much as it's electronically possible. It's not possible if the injector has mechanically failed and is squirting fuel straight in there, or if the circuit going to it is shorted to ground and is squirting fuel straight in there. The PCM can't do anything about that, but it wants to protect that catalytic converter because it's on them for the first 80,000 miles, and they don't like buying catalytic converters under warranty. Open intake air temperature sensor is a fruit basket turnover thing. It may not give you any symptoms at all, or it might. In the early days of throttle body injection, if this sensor failed, it would make it run super, super, super rich. Okay, later on, the one I'm thinking about right now, I was over there helping out at the Ford place during one of my days off when I was teaching, and they had a Dodge truck that had come in the summertime for some work done. They had a lot of work to do to it, and there was a cold snap. Got down to 40 degrees. They wanted to bring it in. It wouldn't start, and you could smell gas. So they said, hey, what's up with this? It was starting just fine. And so I went out there and I checked, and the intake air temperature sensor was wide open. Well, on that Dodge, it was substituting a temperature of 101 degrees Fahrenheit and using that for its algorithm. But the engine coolant sensor was reading the same as ambient temperature, was about 41 degrees. That was causing it to overfuel the thing, wet the spark plugs, and not start. But whenever that temperature was warmer and the engine coolant temperature was closer to that substituted intake air temperature, it would start and run just fine. And it looked to me like the intake air temperature sensor that Dodge had on it was brand new. Like they had pulled a code at the parts store. They sold them a sensor that was open and didn't know it. And when they checked it again, the code was still there. They just assumed that they didn't need it because it wasn't at the time causing any symptoms. But what I did was I got that potentiometer and I connected it in between the two wires at the intake air temperature sensor, looked at my scan tool with the key on, and I dialed in a temperature that matched the engine coolant temp. Fired right up. That's all you had to do. A potentiometer, whenever you're working with sensors, is incredibly useful. Just take that for what it's worth. Test question 9. You always verify the concern before you do anything else. Except I said, don't pull a wheelie like this truck's doing here. I had AI draw that truck, and it's incredible to me how it can take what looks like a Chevy and a Ford mixed. These fenders back here look like a Ford. This looks like a Chevy. The grill kind of looks like a Ford. That thing can draw some crazy stuff. Of course, sometimes it gives people three hands and all kind of junk like that too, if you've ever fooled with that. Anyway, you can check fuel pressure if you want to. You can check spark timing if you want to. You can retrieve all DTCs if you want to. Most mechanics like to plug their tool in to see what the code is. But the smart thing to do, and what the OEMs will tell you to do, verify the concern before you do anything else. If you retrieve the DTCs first, don't clear them until you have stored them all, and including your freeze frame data, and make sure you got all of that stuff, snapshotted or whatever you got to do. You always need to verify the concern before you do anything else. Um, if you just jump in there and start doing repairs without verifying the concern, you may find yourself working on something they weren't even complaining about or didn't know about. And then when you give it back, they say, that's not what I was talking about. I still feel blah, blah. You see what I mean? I don't know. That's even worse whenever you've got a squeak or a rattle or some noise. And you may find yourself working 2 hours on something they weren't even complaining about. If possible, you need to get them to drive the vehicle with you so they can show you what it's doing. I could tell a funny story about that, but maybe another time. It just came to my mind when I said that. When releasing the throttle, the engine intermittently fails to return to idle. If the throttle position sensor is reading part throttle, it will do that because it's in dashpot mode, which is waiting for you to completely release the throttle so it can slowly bring the idle back down. If it still sees part throttle, it's going to hold the idle air control up. You're going to have, see, you're looking for about 700 RPM, right? But you're getting, 35%, 978. And whenever you piddle around with it, what we do is pinch and twist on those wires at the throttle position sensor on the one that this was taken on. And I wound up having to disconnect those wires out of the throttle position sensor and pull the things up to where they were standing up straight, like that. And then the little crimps and the wires looked beautiful. There was nothing wrong with the pin fit, but I soldered every one of the connections where the wire was connected to the terminal. And when I put it back together, it never gave that problem again. Ford actually had a bulletin wanting you to replace the connector and the TP sensor for that. But all you really needed to do. I also fixed my dad's vehicle one time because it turned on a check engine light, was running funky, and it kept throwing codes. And a replacement mass airflow sensor, which was the code it was pointing at, didn't do anything. So I pulled the wires out of the connector and I soldered those the same way I did that TP sensor and fixed that one there. And so sometimes it's something like that. On some of the older Fords that I used to work on, they had these little split pins in the, split female pins in the PCM connector. And I would go in there sometimes when it was giving wacky, crazy problems, and I would just take the little wedge out of the PCM connector, and with a pick tool I would very gently pinch all of those split terminals where they were a little tighter so that they weren't fitting loose on the pin that was in the engine controller. And then I would put that thing back together and fix all kinds of problems that had been beating people up. And so, just a lot of the times it's something really simple. There was a Dodge Charger one time along with one of my students, and when he would turn, it would cut out. And so his mother opted to take it to the Chrysler place. And so they worked on it and changed a bunch of parts and charged him about $2,500. And so he said it was still doing exactly the same thing. They wouldn't really do anything about it at the dealership he went to. And so I says, well, let's just see what you're losing, and we're going to start by checking your cam and your crank by back probing the connector at the PCM. So we back probed the connector at the PCM and connected our oscilloscope so we could watch the cam and the crank while he was driving it. Well, as long as those pins were, back probing the PCM, there was no concern detected. We'd drive and drive and drive and drive and drive and turn and turn and couldn't get anything. As soon as we pulled those pins out of that PCM connector, it started doing it again. That was a pin fit issue that was missed to begin with. And it turned out that when we stuck those pins in there, it would pull the connector off sideways where it would make a good connection. And so all that took was a little bit of tweaking of the pins in the engine controller connector that were going to the cam and crank sensors. It could do it on any pin, though, that might have an impact on the way it did. Anyway, that's an example. Throwing parts at one, which a lot of the times they do, if they can get you to agree to it, it can be a total disaster, But anyway, I could go on and tell stories for a while, but I'm going to finish up this test. Let me know how you did on the test. Share the video. Tell me whether I did a good job or whether this test was a waste of your time. We'll talk to you guys later. Hope you have a great week, and I'll see you next time around.